This is our last video lesson for this unit and for the year. So in this video, we're going to be focusing on solving exponential and log equations. And we're going to use our old properties of logs and a few new ones to help us do that. So the first new one I want to talk about is the one-to-one property of logarithms. So one-to-one just means that they match up. What looks like that it should be equal to each other is going to be. So notice that I have log base 3 on this side of the equation and log base 3 on that side of the equation. And then I have two different things that is behind each log base 3. Well, if these log base 3s are equal, then I know those values after them are going to be equal. And then how would I solve this? Well, this has an x squared in it, so I would get everything on one side equal to 0, so I would subtract the 24. And if I can, I'm going to try to factor this. So remember, when we factor, we try to break that up into two parentheses, and I need two numbers that multiply to give me negative 24 and add to give me 5. So one's going to be positive, one's going to be negative. So if you do that, you're going to get positive 8 and minus 3. Those multiply to give you negative 24, add to give you 5. And remember, we set each of these equal to 0 and solve. So our two answers would be x equals negative 8 and then x equals 3. This is a 0 and I added 3. Now, always, just like in rational functions, we want to plug those back in and make sure that they make sense. So if I plugged in log base 3 of negative 8 squared plus 5 times negative 8, then this would give me 64, and this would give me minus 40. So yeah, that would be a log of 24. So that's okay. And then if I plug in 3, that would be okay. The only thing you have to really worry about are those negatives. So, okay, so always double check to see if these values give you a negative after the log. To make sure you don't do log of a negative number. Okay? We can't take log of a negative number. Remember that it has that vertical asymptote. All right, so we could do the same thing here with part B. We have log base 8 on both sides. So that means x squared will be equal to 16. Now this is a quadratic, but since I don't have an x, I can just square root both sides. And don't forget to write your plus or minus 4. And then again, if I were to plug that in, the negative 4 will get squared, so that'll make it positive. So both of those answers would be okay as well. All right, that's our one-to-one property. It makes things nice and easy. I want to remind you about how we use the definition of log to rewrite either in exponential form or logarithmic form. So that's what we're going to do here. So always ask yourself, can I plug this in to the calculator? Can I do 10 to the x power? Will it give me a number? No. So I need to rewrite. So rewrite in exponential form or log form to solve. Pardon me. So you'll need your calculator. I'm going to rewrite number 1 as a log. Remember, x is the exponent, and your exponent is always equal to log base 10 of 32. Now, can I do log base 10 on my calculator? Absolutely. So we're just doing log of 32. And it says to round to the nearest hundredth, so I'm going to write 1.51. That would be my answer for that one. Okay, so do the same thing here. I cannot do this in the calculator, so I need to switch it into log form. So x is the exponent, which is equal to log base 10 of 1.76. So you're typing that into your calculator, and you get 0.25 if you round to the nearest hundredth. And then over here, same thing. X equals log base 10 of 1 over 200. So if we do log of 1 divided by 200, that gives me negative 2.30. So we've done one similar to that, so this should look pretty familiar. So hopefully we're okay with that. Now in these, the variable changes where it's located. So again, always ask yourself, can I do log base 10 of v? No, I can't do that in my calculator, so I need to switch this now into exponential form. So remember, this is my base, 10 is my base. It's equal to the exponent, so this is my exponent, so it's going to be 10 to the negative 3 is equal to v. So can I do 10 to the negative 3 on my calculator? Absolutely. So that's going to be equal to 1 over 1,000. Okay, so same thing over here. Can I type in log base v? No, I can't do that. So I need to write this. This is my base. V is my base. This is my exponent, 2. So v squared is equal to 49. And now we solve that just like we did in that previous problem. Just take the square root on both sides. So we get plus or minus 7. All right, and then over here, can I do log base 16 of 4? Well, yes, with the change of base formula, we can. Remember, change of base allows us to do log of that big number divided by log of the base. So if I type that into my calculator, I get 0.5. Now another option that you can do, since this one is very easy to do, you can switch it into exponential form and say 16 is my base, v is my exponent, and that's equal to 4. So 16 to what power equals 4? That would be 16 to the 1/2 power, or to the 0.5 power. Remember, the half power is like the same thing as doing the square root of 16. Okay, so a little reminder there if you wanted to do that without your calculator. All right, so can I do 7 to the x power in my calculator? No. So change it. This is log base 7 of 80 equals our exponent. So I'm going to type in my change of base. So I'm doing log of 80 divided by log of 7. Okay, so let's do it. Log of 80 divided by log of 7. And that gives me 2.25. And again, I'm running to the nearest hundredth. Excellent. So try these next two, so B and C on your own. Pause the video and see if you get the same answers as I do. Okay, so on this first one, I got 1.43. Again, I just changed it into log form and then used the change of base formula. Remember, when I don't write anything right here by the G, I don't write my base, that's understood to be 10, right? So this is like base 10. So keep that in mind. That's so you can type that into your calculator. Over here on part C, I got x equals 4. So hopefully you are okay with that. If not, make sure to ask me in class. And then on D, what's going to happen with this? Well, we're still going to do the same process. That's my exponent, so I'm going to have my exponent is equal to the log base 4 of 100. So I'm still going to do my change of base. It's just instead of having x equals that, I have x plus 1 equals that. So I have log of 100 over log of 4. So I'm going to get that value in my calculator. So I have x plus 1 is equal to 3.32. So now if I want to solve for x, I just subtract 1. So this is going to be x is equal to 2.32. So that's all that's different. At the end, you have to do one more step. Okay, so try these on this page and see if you can get the same answers as me. Okay, so I just did the next 3. We'll save the other 2 for class. But on E, notice that All I did was set it equal to the log, the exponent equal to the log, type the change of base formula into my calculator, and then at the end I added 3. So you should be getting 7.64. Same process on f, and you should get x equals -1. This one came out to be a whole number because 27 is a power of 3. So I don't know if you realize this or not, but 27 is the same thing as 3 to the third power. So that's where you could have just, if you recognize that, you could go straight to that x plus 4 equals 3, because these exponents would be the same since the base is the same. And then I wanted to make sure we did one of these. So we had 2x minus 7 is equal to the log. And you do the change of base formula again. And once again, we're getting a whole number. And that's because 216 is the same thing as 6 to the third power. So again, if you recognize that, you can go straight to saying 2x minus 7 is equal to 3. And that might save you some calculator work. All right? So, but then if you add the 7 and then divide by the 2, you should get x equals 5. All right, and then we'll save those other two for class time.